Alright, so let's start with the binary tree. Alright, so what is a binary tree? A binary tree is a data structure which is a hierarchical data structure and where each node has at most two children. Alright, and those are referred like left child and the right child. Each node contains data and its references or links to its children. Okay, so let me visualize that for you. Binary tree. Alright, I create a new file, binary tree.ps, and here is the root of the tree, and let's say this, and here like this, and here we have left and like this, and here we have right, the right child. Now this left and right can have the same thing as its root. So here let's put on left, so here left, and like this. So what will happen here, left again has, let's say, left 1 or maybe L1 and L2. In the same way, right will also have R1 and R2, and this will continue. So this is called as a binary tree data structure. Alright, now let us implement this data structure in Typescript. What will I do is that I will create a class tree node of type, generic t will be accepted, data will be of type t, and it will have a left node and right node. So this tree node will be the one that will combine to make a binary tree, and you will see after the implementation of this tree node. So tree node of type t, or maybe absolutely nothing, so maybe null. Alright, same goes with right, tree node t null. Okay, and constructor here data of type t, this dot data equals to data, this dot left equals to null unless you explicitly specify, this dot right equals to null as well. So whenever you create a node, it will be an empty node. Okay, I mean it will have absolutely nothing other than its data that it is storing, so it has no child. Okay, now let us create a class binary tree of type t, and here what I'm gonna do is that constructor, not an empty constructor, because private root tree node of type t or null is initialized as null. Okay, like this. And now what I'm gonna do is that I'm gonna implement some methods. The very first method is how to insert a node in a binary tree. So I will name this function insert data type t, and it will return absolutely nothing. So void const new node equals to new tree node data. Alright, and what I'm gonna do is that now, if let's say you don't even have a root, you don't even have a root, then this node will become your root. And you will return. Else, let's use a queue. So I have already taught you the queue data structure. You can follow that. So this will have the root. Now, while queue.length is greater than 0. So here what I'm gonna do is that I'm just gonna go through our tree and find where is our empty node. Okay, and then there I will insert. Okay, so what I will do, const current equals to queue dot shift, means we are removing a node from the end of the queue. I mean, we are removing an element from the end of the queue. Okay, and now that will be our current node. Alright, and you will know why. So if this does not have a left node, then its left will be the new node. That's it, nothing else. Otherwise, if it has, then what we will do, we will push it to the queue. Queue dot push current dot left. The same way I will do for right. Okay, so I'm gonna copy that, right current dot right will be the new node, otherwise this. Okay, yeah. So here what we do is that we push the current dot left because it exists, we push the current dot right as well because that also exists. Now we are removing that. Okay, like first the right one is there. Okay, we shift that. Okay, we remove that from the queue because we do not want to insert multiple elements inside a queue and skip them and end up inserting at a wrong position. So that's why we remove the last element, and here we check if it does not have a left side, then we assign a new node there, otherwise we push that to the queue, and if it does not have the right side, then we assign it to the right and return. So whenever we find a side, I mean a left or right side, where we do not have a node, means where the value is null, we suddenly assign a node there and then stop our function. Alright, that is how you insert a node in a binary tree. Alright guys, now another method is in order traversal. So before that, let me tell you what is the in order traversal. What exactly it is. So see, when you are traversing through the binary tree, means when you are moving from each node, moving through the each node of binary tree, there are several ways you can do that. Alright, there are several ways you can do that, and one of those methods is in order traversal. There are other methods like pre-order traversal, and there will be post-order traversal and level order traversal as well. So that also we will know what exactly they are. But for now, let me just tell you what exactly is this in order traversal. Okay. So the in order traversal means that a method of visiting all the nodes in a binary tree in an order of from left subtree to the root node to the right subtree. Alright, so I'll write in order traversal left subtree to the root to the right subtree. Means for any kind of given node, you first traverse its left child and all its descendants, then visit the node itself, and finally traverse its right child and its descendants. Alright, that is what the in order traversal is. Now you will see the implementation of this in order traversal. Alright, so I'll create a function in order traversal. It will return an array of the data which can have t type. Alright, the t type it can have const result t equals to an empty array. Now I'll create a helper recursion in order equals to node t node type t or null if the node is there in order node dot left. So first move to all its left descendants, then result dot push node dot data. Whatever you saw, just push it to the result, and in order node dot right. Alright, like this, and in order root, and then return the result. So what did I do right now? You see, first I just created a result array, then I created a helper function which will undergo recursion. Recursion means the function starts calling itself until the base case is satisfied. So here you see, if the node is there, the node you have provided, if it is there, it will search first it's all the left descendants, so this function is called again, and then it will come to left and call again. But here this will also do this, and it will also go through the right descendants. Okay, this is how you do the in order traversal. Got it? Now what I will do is that I will be doing the pre-order traversal. pre-order traversal means first you will go to the root and then you will go through all the left descendants and then to the right descendants. So basically I just copy this function and paste here pre-order traversal, and this will be moved above. That's it. There is no rocket science, and here I will rename this pre-order. That is how you do the pre-order. Means first, starting from the root, first you add the data, and then you start looking at the left descendants, you start looking at the right descendants. Okay, start from the root and then left, then right. That is the pre-order traversal. Now the post-order traversal. Okay, so pre means the root is like before, root and then left and then right. So root is before, this is pre, this is in, and now the post, left, right, root. Alright, you will see how. And post order traversal, and I will rename this post order, and here I will move this to very last, like this. You go through all the left nodes, you go through all the right nodes, and then you add this to your result. Okay, that is how you do the post order traversal. Alright, now we will do this level order traversal. Means BFS, breadth first search, or level order traversal. So you traverse here horizontally from left to right, and then next left to the right. Means you have a left node, you have a right node. Those left and right have L1, L2, R1, R2. So you move from L1 to L2 to R1 to R2, and then you go below. So L11, L12, and L21, L22, and the same way R11, R12, R21, R22 is horizontal traverse. That is what we call BFS. Now what is DFS, depth first search? Whatever we did this till now is called as depth first search, because we are going to the depth. Left, then it's left, then it's left, then it's left, then right, then it's right, then it's right, then it's right, going down and down and down. That is depth. Here you will be going horizontally in a breadth first search. So this is also called level order traversal. I will be naming this function as level order traversal. You can rename it to whatever you want. Level order traversal of type T, array of T, and here what I'm gonna do is result the same thing. Oh, sorry, and like this. Now if there is no root, then return the result, an empty array. Now let's create a queue. Which is an array of nodes and starting with this dot root. Now while this queue has elements or nodes, anything that is present inside an array is called an element. Okay, so you can call node or element or whatever. So const cur equals to queue dot shift. Remove that from the queue and pick it up. Okay, now you push that. You push its value, and then what you do is that you add the left side, you add the right side to the queue, and I will tell you why. Oops. Dot right. Okay, let me add semicolons as well so that we can avoid any confusion. So here what you are doing is that first you create a queue starting from the root. Okay, you push the root data. Okay, and then if it has the current dot left, means if it has the left node, push it to the queue. If it has right, push it to the queue, and then you see that you get the right one, you shift, you get the right one, you push it. Okay, if it has left and right, you see that will also be added. Okay, you had this left one as well, so if you get that, there also you will be going to add it to the result. Okay, that is how you are going to do the breadth first search. Alright, now let's implement some other methods like get the height of the tree. So how we are going to get the height? So we will be utilizing recursion here. Const calculate height equals to node tree node t null number and one thing. Alright, now if there is no node, then return 0. Okay, otherwise first we will go through the left height. Calculate height node dot left right height, calculate height node dot right, and return math dot max left height right height plus 1. Alright, like that. Since we are starting from 0 here, so that's why we are doing this plus 1, and then we will return this function. So when we return, this will be called, it comes to the node. If it returns 0, then this will be returned otherwise. So this will be returned left height and right height. Okay, it will be calculated this way. Okay, That is how you get the height of a binary tree. Now, get size means get the number of nodes in a tree. So again we will use the recursion. So the same thing only, like this, and number here. If there is no node, return 0, otherwise return calculate size node dot left plus calculate size node dot right plus 1. Okay, and return calculate size root, like this. Okay, so again we are using recursion, and then calculate all from the left and all this from the right, and this plus 1. Okay, so because since you are starting from the roots, that is 0, that's why I did this one. And then it will keep calculating, it will keep calling the function until the base case is satisfied. Value will be returned, and this is how you will know the size. Now check if it is empty. Boolean return root. No. Alright, there is no root means it is empty. And if you want to clear this, clear this dot root equals to null, means everything from this binary tree will be removed. Okay, now let us try to use our binary tree. Okay, now I'm gonna use my binary tree. I will first instantiate new binary tree, type will be number, and like this. Now binary tree dot insert 2. I will copy this like this, 3, 4, 5, 6, and now let's do some traversing. Binary tree dot level order traversal, binary tree dot in order traversal, like this, and like binary tree dot get height. Should I run this? And yeah, 2, 3, 4, 5, 6, and here you see 2 and this 5, 3, 6, 2, 4. We just need to visualize that so that we can understand. But anyway, now this was the in order traversal, so all the left nodes were traversed. So 5, 3, 6, all these were left, and then we came to the root and then to the right. That is how so we visualize. Level order traversal 2, 3, 4, 5, 6 in the order that we inserted. Now get height. Height is 3. So towards the root, it had 3 and 5 to its left, and then 5 had 6 to its left. So the height is 3. So that is all about the binary tree in TypeScript. Next we are going to see the binary search tree.